conferencia plenaria del Fourth International Conference on Mathematical Modeling. Para mí es un honor presentar al doctor Paulo Canas Rodríguez, quien amablemente aceptó nuestra invitación para participar como ponente plenario. Voy a comentarles una reseña de nuestro ponente. El doctor Paulo Canas Rodríguez es licenciado en Matemáticas de la Universidad Nova de Lisboa en 2003. Obtuvo su grado de maestro en Estadística de la Universidad Técnica de Lisboa en 2007. Obtuvo el doctorado en Estadística de la Universidad Nova de Lisboa en 2012 y obtuvo la habilitación en Matemáticas especializada en Estadística y Procesos Estocásticos de la Universidad de Lisboa en 2019. Tiene experiencia en el área de Estadística, con énfasis en aprendizaje estadístico, reducción de dimensionalidad y visualización, series de tiempo y análisis espectral, métodos sólidos y ciencia de datos, entre otros. Ha publicado más de 50 artículos en revistas científicas internacionales y actualmente es editor de la revista Statistic Optimization and Information Computing desde 2013 y coeditor de la revista Biometrical Letter desde 2013. En sus actividades profesionales, interactuó con más de 70 colaboradores en la coautoría de artículos científicos de 17 países y recibió 20 reconocimientos entre premios, honores y becas. Actualmente es expresidente de la sección regional latinoamericana de la Asociación Internacional de Computación Estadística, miembro del comité ejecutivo de dicha asociación y presidente de la región brasileña de la Sociedad Biométrica Internacional. Es líder del grupo de investigación, estadística y ciencia de datos, acreditado por la Universidad Federal de Bahía, y vicecoordinador de la especialización en ciencia de datos y Big Data, también en la Universidad Federal de Bahía, de donde nos impartirá su conferencia. Entre 2015 y 2019 fue director de investigación del Centro de Estadística y Análisis de Datos de la Universidad de Tampere en Finlandia. Su equipo de investigación y algunos de sus proyectos de investigación en curso se pueden encontrar en el sitio web del Laboratorio de Aprendizaje Estadístico, del cual nos mencionará en su plática. Vamos a dar la palabra al doctor, quien nos expondrá su presentación, para que al final pasemos a la sesión de preguntas y respuestas. Adelante, doctor.
Gracias. Buenos días a todos. Yo quiero agradecer al doctor Jiménez y Verónica por la invitación. Yo estoy aprendiendo, estoy haciendo cursos de español, pero no lo sé lo suficiente para hacer una presentación completa en español. Entonces voy a hablar en inglés, pero en la sección de preguntas y respuestas pueden hacer las preguntas en español y yo voy a responder en inglés, ¿ok? So today I'm going to talk a little bit about, this is a general talk on statistics and data science. The main aim in all this field is always to transform data in information. I would like to thank again the invitation. It is a great honor for me to be speaking in the 4th International Conference on Mathematical Modeling. It is a pity that I could not visit Mexico to give this talk, but I'm sure that we'll have another opportunity in the future. So now we cannot do anything about it. So why should we be worried or should we think about statistics and data science? Because statistics and data science is everywhere. If you use Google, if you use Amazon, Netflix, you see that you always have this page rank or these suggestions for new movies or new series or new books. This is based on computational algorithms and statistical analysis. In the last several years, the amount of data that has been collected has increased immensely. So everyone has heard about big data, about unstructured data. I will talk a little bit about those in the following. And here I'm going to talk a little bit about in which way statistics, computer science, and computer science and data science are very important in everyday's life and every discipline. I will present a few big data applications. I will talk a little bit also about machine learning that everyone is mentioning nowadays, and also a little bit about Internet of Things and artificial intelligence. So I'd like to start this talk this is I think it is done by Marie Davidian and Thomas Lewis from North Carolina, John Hopkins, respectively. And this is all they define statistics. They define statistics is the science of learning from data and of measuring, controlling, and communicating uncertainty, which, if you think carefully, is very near of what the definition of data science has been associated to. And thereby provides navigation essentials for controlling the course of scientific and social advances, which means basically that you can find this kind of usefulness across all the scientific areas. I also have this paper that probably most of you already heard about. The title is 50 Years of Data Science. It was written by David Donovan from Stanford. And essentially, he's talking a lot. It is a very nice article to read. And he is making some comparison of John Tukey's statistics and the data analysis with the current names and current discipline called data science. So it is a very nice article that if you have the chance, try to take a look at. It gives an overall perspective on the importance and development of statistics in the context of data science. This is already a phrase. I put this in several of my talks, this slide. Al Varian is the chief economist at Google. He was the chief economist in 2009, and he gave a very special statement in one of his public appearances. He said what is written in this poster here. What he says is, "I keep saying that the sexy job of the next 10 years will be statistician." And of course, this is a very strong statement, and is even stronger when it comes from the chief economist at Google. So I think was, although it was already more than years ago, I think it is a very important statement, and I do believe that it is still very true, as I will reinforce later on. But by chance, I could meet Al Varian in 2015. I attended a conference in Rio de Janeiro, in Brazil, the ISI World Statistics Conference. He was one of the keynote speakers, and I think so. This is the picture, and I had like 30 seconds or 60 seconds talk with him, and I just briefly thanked him for this kind of point of view, because that was a big boost for the way that people look at statistics. And what he said is something like this: "I only said statistics is sexy because we have many models." So it was it was a short conversation, but very fun. So I was really happy to have the chance for this small interaction. So I don't know if you know about careercast.com. So this is a website that lists the best and the worst jobs in the United States. Of course, Mexico and Brazil are a bit different, but in some way, the trends, the global trends are similar. If things that did not happen in this way, they will go in that direction at some point. So this is for 2016. You can see that the best job, so they use several variables. Three of them are those listed there, are the work environment, stress, and hiring outlook. So those are three of the variables that they use to create this list. And the first one on the list was data scientist, the second statistician, and then mathematician, the sixth place. So I think in our field of work, I think we are quite in very good positions. So this is 2016. I also have to 2017. Now there is statistician in the first, data scientist in the fifth, then university professor and mathematician. 2018, we have mathematician now to over, so it is second place, then university professor, statistician, data science. So we have data scientist as number one, statistician number two, university professor, as many of us are, number three, and mathematician number 8. So I think this gives some kind of indication that we did some good choice in life for choosing statistics or mathematics or data science or becoming university professor. So we are on track. So the era of big data, everyone is hearing a lot about data science and big data. There have been many special issues in many journals only for big data. Here I have some examples already for a few years ago. We have something on the Nature, all of these popular scientific magazines. So I have here, this is already a definition from 2012, but I decided to keep it in this talk because I like it very much. Because this is something that was written in New York Times. And basically they were asking, what is big data? What is it? And they start saying, that it is a name and a marketing term. Of course it is, because big data and data science, they sound very well. But is also a new approach to understand the world. And I will talk a little bit about that later. And another question, why is big data big? Because it is not just more data, it's different data. It's data that is simulated in different times and different resolutions. Because up to several years ago, a data set used to be a table which you have individuals in the rows and variables in the columns. But nowadays, data is something else. Data, of course, is that. That is still data. You also have images. You also have posts. You have text. You have a lot of things that are unstructured data, and they should be analyzed as well. Where can you find this data? You can find it in social media. You have plenty of data in social media. There are a lot of sensors for climate, for traffic, for everything. For instance, if you use Waze or Google Maps, if you go from one point to the other, these apps or these services can tell you how much traffic there is in that way, what is the best route. So all of that is based on this data that is open. And of course, we are the ones that are providing that data, right? Because Google Maps knows if there is traffic in a single road, if there are many people stopped in that road with a phone. All of us are with a cell phone with us all the time. So if we are stopped, if there are a lot of people in the same place and that place is a road, it means that probably there is traffic there. And that's the information that we give to Google, and then that Google gives back to us to tell us that there is traffic in those parts. Also purchase transaction records. In some places, I don't know it is in Mexico, but in some countries, the big supermarkets, they have a card, they have associate card. And when you use that card, you get a very small discount for the things that you buy in that supermarket. And of course, everyone is happy to get some. We are putting more card because we are telling the supermarket what kind of things we buy and how we buy them, when we buy them, what is the frequency, all of that. So it might very well happen that one day you go to the supermarket and they ask you, well, every week you buy chocolate. Why don't you buy chocolate today? Did you forget that? So this is a way of data that we are giving them, of course, for advertising purpose and these kind of things. And of course, mobile GPS signals, digital satellite images. This is there has been a lot of talking in the recent weeks about the fires, especially in the Amazonian forest. Of course, the area that the wildfires are burning is measured by satellite images, and also administrative and transactional records. And of course, Google provides a lot of data. I was searching online for some formal definition for big data, and then I found out in the IBM website this statement here. So what they say is that big data analytics, so the analysis of big data, is to use advanced techniques against very large, diverse data sets from different sources and different sizes, from terabytes to zettabytes. So basically, what they say is that big data analytics is to use quantitative and analytical techniques for large data sets. And these data sets can be diverse, can have different sizes, different sources, different formats, etc. And this kind of data, the sizes usually in this definition from IBM is that it goes beyond the ability of the traditional databases. So basically, many people say that, oh, well, there is big data if I cannot deal with it in my personal computer, something like that. So, and this data comes from sensors, video, audio, images, log files, etc. And for big data, the most standard definition is the three V's. There are another V's that can be included, but there are three main V's. And one of them is volume. Volume is, let me see, I have here. I see that there are some questions. I will answer them in the end. One of them is volume. Volume, we are talking about terabytes, petabytes, zettabytes, etc. So it's one of the main directions for data to be big. Another one is velocity. Velocity, I can interpret it in two ways. One is the velocity that the data is being recorded. For instance, you have sensors that they are collecting data every second or every millisecond. For instance, I was with one of my students, I'm analyzing EEG signals from the brain. So basically we have a few thousand observations per every second. So this is really very, very many observations per a short period of time. So this is one of the things, velocity in the way that the data is being collected. But there is also another one, is the velocity in which we can analyze it in a useful way. For instance, imagine that you have a stock market of Facebook, for instance, and you want to predict what is that stock going to be in one day, for instance. Should I buy or should I sell? So you want to predict what happens in the day after. But imagine that you have a great model. It is very accurate, but that model takes 2 days to run. So it is of no use anymore because you are taking longer to predict than the time until that prediction happens in reality. So this is also a very important thing in velocity, and this is why it is important to collaborate with people from computer science, because we statisticians are not so much into algorithms. We are more in models and methods. And for a very efficient programming structure, I think computer scientists can be of a great help and support. And the third V is variety, as I mentioned before. So we can have standard matrices with data. We can have audio, video, click streams. I was watching a video that maybe you saw, maybe some of you, is a documentary from Netflix. Is the social dilemma is about social media, and the things that they measure in social media is not just how much time you spend in a given page. They measure how many seconds you spend in each picture, how many seconds you spend in the page, how many clicks, where you click. So all of this that you do online is being measured. So this is a huge variety of data. And in this slide, I have, like for data science, a kind of skill set. You can see that you have scientific math, you have mathematics, statistics, advanced computing, visualization, etc. One important is the domain expertise. Because, for instance, if I'm analyzing some data from chemistry, I don't know chemistry enough to make specific conclusions. So I can make the conclusions in terms of statistics, but not in terms of the domain. So this is why it is important to have someone in the team that knows chemistry, that knows the right questions and how to interpret the results. So this is always important. And because there are so many skills that you need for data science, this is why I write here that this is a team sport. Because indeed, you don't have anyone that can be expert in all of those skills. So you need a set of people that can contribute to make larger advances. And in this slide, I have here a plot that I found in this link that you can see in the bottom of the page. And you have here 2 axes. The horizontal X is the business value, the vertical is the analytics maturity. If you look in the diagonal, you can see that in the lower left corner, you have the data quality. So this is where we spend a lot of time. A major part of the time is to put the data ready to be analyzed, because you see the data is, if you are dealing with big data and with real data, observed data, you have many possible problems. There are a lot of missing data, lots of wrong values, outliers. So to clean the data, to make it ready for any kind of analysis, it really takes a lot of time. The second step is to do a descriptive analysis. As soon as you have a data set that you can analyze, the important thing, in my opinion, is to understand what kind of data you have, what kind of relation do you have between the variables, all your data is. So you do some descriptive statistics, some visualizations, and you can have a global idea all the data looks like. And then, of course, you have also a set for diagnostics, for some kind of modeling. You have, depending on the data, you can adjust a lot of models, univariate, multivariate, Bayesian, classic, etc. And as soon as you have a model, you can do some predictions. You have the predictive part. And then the last part, the semantic, it depends on the kind of data. Then you are looking for some kind of relations. So this is more or less what the path between the beginning until the end. And I also would like to talk a little bit about Internet of Things. Internet of Things, I don't know if all of you heard about it. Things are objects. So are objects which have electronics, software, sensors, and network connectivity. And all of this enables the objects to communicate with each other and to exchange data. So for instance, a smartphone is one of these things, or a smartwatch, or something like that. And these are the things. This term "Internet of Things" was coined by Kevin Austin in the MIT in 1999. So it is already more than 20 years old. But now that technology advanced, this is being more used and more analyzed. So these are some numbers. So in average, we should have about 26 objects per person on Earth. So now in 2020, it is estimated there are 200 billion smart objects around. Of course, I don't have 26 smart objects, but if you look at several companies, in particular business and manufacturing or healthcare, they have most of these objects, of these things, these smart things. If you see in this slide, about 42% of all these wireless objects, wireless things are in the business and manufacturing. For instance, you might have a machine in a company that has many sensors. One sensor for eating, one sensor to detect if something is near or it is far. So there are many sensors in this kind of machines, so that we are sure that they are working properly, and that if they have some kind of possible failure, we can predict it before it happens. Because you see, for instance, if you have an elevator, and of course you have a lot of sensors in the elevator, it is important to have some kind of red flag when something wrong happens, before it happens, right? So we should be able to predict, because that can cost the lives of people that are inside. And same for some other machines. And I will come back to this kind, because these things, this Internet of Things, are mostly sensor data. So I will talk a little bit about sensor data in a while. For instance, the sensors, the Internet of Things sensors that can help in industry innovations. This consultancy company, Frost & Sullivan, they estimate that 40% of all IoT data that was generated until 2020 came from sensors. So sensors that are measuring things along the time. So every second you are getting a new measure. And 60% of all these wireless IoT devices are purchased and used by enterprise and industries. So the industry is really giving a lot of attention to this kind of data collection and data use. Something that is quite interesting. This is already from 2013. In 2013, 30% of all manufacturers that were surveyed in by this study already have parts of their factories connected to smart sensors. So this was already 2013, and since 2013, that increased a lot. In one of the surveys that was made for these industries that use sensor data, what they say is that the efficiency increased. So 82% of the people that were surveyed said that the efficiency in terms of production increased. 49% noticed fewer product defects, because if you are able to predict what is going to happen based on the sensors, the data that you are being collected. You will be able to predict when there is something wrong so that you can avoid it. So you can reduce that a lot. And 45% experienced higher customer satisfaction levels. This is something I decided to put this slide here because it is connected with what I mentioned in the beginning about the importance of statistics, mathematics, and data science. This Alteryx is a consultancy company that makes some surveys, among other things, and they did one in Europe. And what they found out, what I want to point out, is that 50% of these business leaders that they interviewed, they said that data and analytics savviness is one of the two most important skills for a new employees. So basically what they are saying is that one of the two most skills for hiring a new person is the ability to analyze data, is the ability to deal with quantitative data. And they go a step further. They say that data and analytics is now considered more important than industry experience or a second language. You see that we are talking about Europe. Europe is not like Latin America. In Latin America, basically you speak Spanish or Portuguese, and everyone can speak one of the two languages, and most people can understand both. But when looking at Europe, that's where this study was conducted. We are talking about small countries, and each country has a different language, and they are very different from country to country. So to state that it is more important to have analytical skills than experience or a second language, that's a very strong statement, because a second language is what makes people in Europe communicate with each other, while in Latin America, maybe you don't need the English as you need in Europe. So this is a really strong statement. So I have here some examples. Here I have information of what happens in 1 internet minute. I'm not going into details because I have one slide after about this, but if someone wants these slides, I can share them with you. So I have here some fun and some amazing facts. For instance, in Google, there are being made 3.5 billion searches per day. That's a big number. In Twitter, 500 million tweets every day. I also have numbers for Facebook, Instagram, but I think this is most important. This is data from 2019. What they say is that every minute, on average, 500 hours of video are uploaded on YouTube. 500 hours per minute. This corresponds, so let me try to put this in perspective. If I decide to watch all the YouTube content that is being uploaded in the next 24 hours, so if I decide to watch all the content uploaded to YouTube in the next 24 hours, I will spend 82 years. So in 24 hours, 82 years of content is uploaded on YouTube. So this is really something very, very impressive. I have here a very interesting example. This is about a company, I think it is a public company. It is called Transport for London. For those of you that have already been to London, you know that when you get there to use public transportation, they have a card called Oyster Prepaid card. This is like a small card that you can use for most of the transportation there. So what they did was to collect all of that data from everyone and try to make decisions based on that. So what they did, this is a statement from the head of analytics at Transport for London. And what he's saying is that by analyzing that data, they could understand what is going on, what happens. So how crowded a particular bus or range of buses are in a certain time of the day, for instance. In this way, they can plan what to do. So if there is a line that it is very crowded in a given moment of the day, they can put another bus, for instance. So and then they can also minimize walking times. For instance, if you have two bus stops or two underground stops, if one has more people than the other, of course, if you are renting a space for a store, you are charging more in the station that has more people. So this helps them to make things more fair and to give some contribution to people to avoid crowd buses or to reduce the walking times. So this is one of the applications that can be used with all this data that comes from these cards. I have here some examples of the IoT revolution. Imagine, for instance, that you go to a store, you want to buy some clothes, and you don't want to try them. You want to just, because some people like to try clothes, some other don't. So imagine that they have smart mirrors that can allow you stand in front of the mirror, you choose which clothes you want, and then they put them on you digitally to see if you like it or not. Or for instance, to assembly line sensors that then detect even small decreases in efficiency and determine if some equipment, because you see, if you are producing a lot of items, if the efficiency in terms of production reduces only a little bit, it reduces the amount of the production, the overall production. So it is important to keep that on track. Also, these agricultural machines that are GPS guided, and they can plant, fertilize, and harvest crops, and also these possible fitness tracks, so these clothes that you can wear, and they can measure your heart rate and other health signals, and send the data directly to your doctors. And of course, this is not science fiction. This is the next industrial revolution, and is happening currently. Now I would like to take a little bit of time to talk about machine learning and artificial intelligence. I will explain in a moment what's the relation between Internet of Things and artificial intelligence. So of course, artificial intelligence now has been talked a lot, but up to some years ago, we heard about artificial intelligence when we saw the Terminator or the Matrix, for instance. But recently, we have been hearing also a lot about machine learning and deep learning that have a clear connection with artificial intelligence. I will talk a little bit. So, artificial intelligence. What is artificial intelligence? This was coined. This term was coined in 1956, long ago. And basically involves machines that can perform tasks that are characteristic of human intelligence. So basically, a machine is able to do some task that usually is done only by humans. And there are two types of artificial intelligence. You have general and narrow. General is a kind of human intelligence that you are able to do several tasks. Narrow is when you are doing a specific task. For instance, you have a set of images of dogs and cats, and the algorithm is able to tell you, after you train the algorithm with pictures of dogs and cats, then you give some other pictures, and the algorithm will tell you if it is a dog or if it is a cat, basically. So this is an example of image recognition. Now, machine learning. Machine learning is a simple way of achieving artificial intelligence. So is essentially the ability to learn without being explicitly programmed. So basically the algorithms of machine learning, their idea is that they will continue to learn. So you program the algorithm in such a way that you don't have to update it all the time. So you are updating with data, and they are adjusting in a way that they will be able to achieve the goal. So for instance, if you want to predict something, you have a temporal data and you want to predict something, you have to tell the algorithm what's your aim, what is your objective function, and then it will optimize itself in a way that that will learn in a way, of course. Yes, so this is what I mentioned. So machine learning is a way of training an algorithm so that they can learn how to do something. Deep learning. Deep learning is one of the many approaches to machine learning. So deep learning usually is associated to artificial neural networks that are networks that try to mimic what happens in your brain. So they have inputs, and then they have some operations inside, and then they have outputs. And these operations are conducted by hidden layers of neurons. Yes, and there are neurons, and there are several layers of neurons, and because of those several layers, we have the name deep learning. Deep because we are having several layers. So now something important is the relation between artificial intelligence and Internet of Things. So this relation is similar to the relation of human brain and human body. How so? So our bodies are sensors. So we have sensors. We have the touch, we have the vision, we have the audition. So these are the sensors that collect data. So if I touch something that is hot, I get some stimulus. So this is the information that I'm collecting. So this is the Internet of Things. The Internet of Things is to collect the data based on sensors. The difference is that in human body, the sensors are the eyes, the ears, the nose, the touch. So those are our sensors. Artificial intelligence is our brain. So our brain makes a decision. So for instance, if I touch something that is hot, I get that information with my sensor, with my Internet of Things, that is my finger. That information goes to my brain. So the analogy is the artificial intelligence. And my brain processes the information. It is hot, it is not pleasant, so I should do something. So the decision will be to remove the finger from the heat, right? So this is the idea of the connection between artificial intelligence and Internet of Things. So our body collects the data, our brain processes the data and makes some decision, and then the body follows that decision, and it continues like that. So that's the relation between artificial intelligence and Internet of Things. And of course, Internet of Things will make better artificial intelligence and vice versa as well. There are, of course, many advantages for both the industrial side and consumer side.
Doctor, minutos, por favor.
Sí, gracias. On the industrial side, we can have machines that are more efficient, for instance. On computer science, on the consumer side, we have services that are given to us. For instance, it is useful for me to know how much traffic there is if I want to go somewhere. So this is what I gained for providing my data in a way. Let me tell you quickly what I have in this slide. So why is it that we are looking at these things now and not 20 years ago? Because now we have the technology for doing that. We have cheaper and powerful sensors. They can last a lot of time without a powering source. So they have a long battery life. They can send data to the cloud. Now there is a limit amount of data that you can store. So the storage, you can storage everything. I think I will skip this part because this is a little bit a complementary of what I mentioned before. And I would like to talk a little bit about the challenges. For instance, who owns the data? For instance, if you are putting things on social media, even if you delete them afterwards, they will be stored somewhere. So they will never go. So there is a lot of discussion about the influence of social media in elections and in the way that people think and in the way that people decide what they like and what they don't like. So there is a lot of discussion that should be done in that way. In our point of view is the methodological part. We need to think about methods that can properly analyze these large data sets. So what we want is to make big data small, basically meaning that we want to visualize how the data looks like. Of course, in terms of technology, we need the computer power. You know that there are online services that allow you to put code running for whatever time you need. And of course, the people. We need people that are data scientists. What is a data scientist? I think I found this definition somewhere, and I really like it. So in my view, it is a statistical minded person that has programming skills and that is curious. Because of course, you need the statistical thinking, you need to know programming, and you need to be curious because you need to know, okay, why is this data like that? What can I do about that? What is the nice thing that I can extract? What is the research question that I should look at? So all of these questions are very important. All of these skills are very important for a data scientist. And then, of course, we need to extract information from these huge and complex data sets. We need to do it in a reasonable amount of time. We need to take care of this cleaning that I mentioned before, because there are missing values, there are outliers. We need robust methodologies to deal with that. We need the algorithms that are efficient. So in that way, it is important to collaborate with computer scientists that can be more focused on this part. And of course, we need to have visualization because, as people say, one image is worth more than 1,000 words. So many times you look at a picture and you see more patterns in the data than any kind of summary statistics. And this is a big challenge. It's not just for statisticians, but also for data scientists and also interdisciplinary teams. So this is I think the big challenge. And something more thinking about statisticians and mathematicians, maybe. I think we should go more on this direction. We should look at these new tools and new technologies. And we should try to force these collaborations with these interdisciplinary teams so that we can really make larger contributions. And of course, to be up to date in terms of methodologies to respond to the challenges. And very important to look outside our backyard because many times we are very focused on our own research square and we don't want to look outside. So it is important that we do that. And of course, one that I didn't put here is advertising. I think statisticians and mathematicians, I think they lack skills in marketing and advertising. And this is a very important thing because we do many good things, but oftentimes we don't show them. So my last slide is from this paper. I want to read. This is from David Aldous, and it is a conversation with Percy Diaconis. I want to read to you this sentence that is taken from this article. Statistics is as healthy as it has ever been. One can see the prominence of machine learning, but they are really just using ideas that were developed in statistics 20 or 25 years ago. They are applying them, that's great. but we are inventing the ideas that will be applied in the next 20 or 50 years. Statistics is a great field to be part of, and I'm still excited about that. So I fully sign this statement. I think it's one of the best statements about statistics that I have ever read. So that's why I decided to share it with all of you. And these are some of my contacts. If you want to contact me, this is my mail, my website, and my lab. And gracias por su atención. Thank you.
Ok, muchas gracias a usted, doctor Paulo, por su exposición. Vamos a dar paso a la sesión de preguntas y respuestas. Si hubiera alguien de los espectadores de la plataforma, puede alzar su mano. Pero ya tenemos algunos comentarios aquí en el chat. Y hay una pregunta y nos comentan que si cuáles son las técnicas de análisis de datos que deberían de usarse para iniciar en Big Data.
You see, big data is a very general concept. So big data, it can be everything. Every data can be big data. I think this is a very good question and a very difficult question to answer because it depends on what you are looking for. Because something important in terms of software, I think it is important that people know Python and R. I think those are the standard softwares for this kind of discipline. But in terms of maths, it depends on your field. For instance, if you are interested in temporal data, you should look at time series related things. There are, for instance, if you look at neural networks, there are specific neural networks for predicting time series. If you are interested in images, it is a completely different field. It's a completely different model. They also have neural networks only for images. So I think it is a difficult question because you need more details. So you need to think, okay, what is because you see, many of the big data analysis that is done, the initial is descriptive statistics, basically, because the data is so large that it's difficult to fit models without a powerful computer. Sometimes it's even difficult to read the data in your personal computer. So in terms of maths, I think it also depends on the discipline that you want to focus on. So that's if you can provide more details on which kind of discipline you are interested, maybe I can answer differently. But in a general way, I think it's a bit different. Of course, there are things that machine learning. Now everyone talks about machine learning and deep learning. But if you look at machine learning, you have the logistic regression that is one of the most used algorithms. This is a statistical model. And this is for supervised learning. So you have many statistical models that are embedded with machine learning, and they can do several operations.
Ok, sí, muchas gracias, doctor. Una pregunta muy general. Tenemos muchos estudiantes de la carrera de matemáticas aplicadas y a veces surgen algunas inquietudes. Por ejemplo, comenta un estudiante, dice, ¿cuál sería un buen camino a seguir para ser científico de datos si estudié o estoy estudiando matemáticas aplicadas?
So my suggestion, this is a personal suggestion of me. So the mathematical background is extremely important. My suggestion is that for you to take a few courses. I don't know if you have courses in statistics, a few courses in statistics, and to take a few courses in computer sciences. For instance, I don't know it myself, but I know it is important. So it is important that you know programming. Programming is very important. And also databases, to take some course that deals with SQL. So I think those two courses in computer science are very important. And then also some course in statistics. But of course, the mathematical background is of great importance because you cannot avoid that in any way.
Ok. Y bueno, tenemos una participación de Sergio Muñoz. Si por favor puede usted hacer la pregunta al doctor. ¿Tiene usted la palabra?
Sí, gracias. Primero un comentario a manera de introducción de la pregunta. He escuchado varias conferencias sobre este tema y siempre me quedo con la sensación de que estoy escuchando algo así como publicidad de algo, lo cual nunca finalmente aterrizan o, digamos, no llegan a, como hacían en la primera pregunta, no mencionan sustantivamente herramientas o algoritmos. Entonces, en base a eso, yo hago dos preguntas muy cortas. La primera es, al final, ¿cuáles son aquellas herramientas que utilizan o qué es aquello que miran? ¿Miran tendencias, miran promedios, miran correlaciones? Eso por un lado. Y la segunda es, todo el tiempo usted habló como de los beneficios, las oportunidades, las ventajas de esta etiqueta de ciencia de datos, pero me gustaría saber si hay algo así como precauciones que hubiera que tomar, si hay peligros, porque también mencionó varias veces la palabra predecir. Y si el futuro se pudiera predecir, yo creo que no estaríamos perdiendo el tiempo, entre comillas, en una conferencia y estaríamos comprando acciones en un broker.
Gracias, Sergio. Yes, I agree. In the first question about what is the aim, it depends. For instance, you have methods. For instance, there are the I'm talking sometimes on time series because this is one of my main research interests. For time series forecasting, you have the large short-term memory models. Those are neural networks specific for that. So the aim, so you can think about data science in some way of applied statistics. So it depends on what you want to what is your research question. If your research question is to forecast a time series, you can use a neural network that is for that, but you can also use the standard statistical models. So it is a matter of choice and of what is the best method. About the second question, of course there are threats. I think the threats is the amount of data that people are collecting and using without permission. I think this is a really, really big concern because I don't think we can predict shares or stock markets. Of course, there are a lot of models and people try to do that. But I think what people do instead is, with so much data available to some people, is to influence people. So you don't predict what people are going to do, but you influence them to do something. And this is valid for stock markets. It is valid for political choices. So I think this is the threat. There is so much data that we are providing to these large companies, and we are providing that for free, that they are able to influence us, not to predict us, but to influence us to reach a place that someone wants us to go. I think this is the major threat.
Ok. Bueno, pues muchas gracias, doctor Paulo. Vamos a dar por terminada la conferencia, ya se nos terminó el tiempo. En nombre de la Universidad Tecnológica de la Mixteca, agradecemos su participación. ¿Sí? Y nada más le pido que deje de compartir pantalla. Voy a hacerle entrega de forma virtual su constancia de participación y la cual se le hará llegar pues, de forma pues, virtual, ¿no? ¿Vale? Entonces, le damos las gracias al doctor por su participación y los invitamos a continuar y a seguir en las actividades de nuestro congreso. Muchas gracias, doctor.
Thank you again. It was a great pleasure for me to talk to you today. Thank you.
Gracias.